All right, let's take a look at the last 2 pages of this review. So here we're going to be working with some linear models. An industrial furnace is designed so that its temperature changes linearly over time, starting at T equals 0. The F of T gives the temperature in degrees Fahrenheit at time T in hours. Workers measure the temperature and find that F of 3 equals 850 and F of 8 equals 1200. First, we want to find a formula for this linear function. And whenever we're trying to find a formula, what we want is a point and a slope. They gave us 2 points, but they didn't give us a slope. The good news is, if you know 2 points, well, what are those 2 points, first of all? We have the point 3, 850, corresponding to that input and output, then also the point 8, 1200. We don't have a slope, but we can use these to get us a slope by using the slope formula, which is just like the average rate of change formula. So I'll do y2 minus y1 over x2 minus x1. And I have to do a little bit of arithmetic here. That looks like it should be 350 in the numerator. 8 minus 3 is going to be 5. So we have 350 over 5. That's going to be 70. So my slope is 70. Great, I have a point, I have a slope. Now we can go ahead and use point-slope form, which will look something like this. You could also try to solve for the y-intercept, which we're going to actually need to do later on in the next part. But, you know, point-slope form is great, and I'd recommend that you use it at every opportunity. So we'll go ahead and just fill in the blanks here. We had that m equals 70. My first point, let's just use the first point they gave us. And then we'll add 850. And that's it. So we got our equation of the line using point-slope form. Next, we want to use that equation to do stuff. One thing that we'll have to do is we'll need to predict what the temperature was at T equals 0. So, what is that asking us to do? That's asking us to find what's F of 0. So that just means, oh goodness, I made a little boo-boo here. My inputs are given by t's, right? So I should probably have a t here instead of an x. Just a little thing. Okay, so now I'm going to plug in 0 for t. And when I do that, now I just need to evaluate this. So that's going to be 70 times negative 3 plus 850. That's going to be negative 210 plus 850, which should just be 640. Let's get some units on this. What's F measured in? It's measured in degrees Fahrenheit. So let's put some units there. That's my final answer. And that tells me what the temperature was when we started all this. Lastly, it's asking us to predict when the temperature reaches 2100. Now, this is asking us to solve where does 2100 equal F of T. So we'll go ahead and set 2100 equal to 70 times T minus 3 plus 850. If we really wanted to, now that we have the y-intercept, we could write this in slope-intercept form. I don't see any big reason why we need to do that, but you could if you wanted to. Let's start by subtracting 850 from both sides. 2100 minus 850. Why is that? Oh, that was 1200. Now we have 2100, which is a bigger number. I'm not going to try to do this in my head. Because for some reason I just don't want to. So, oh goodness gracious, I know how to subtract numbers. Goodness. So 0 minus 0, 0. We'll need to kind of borrow that 0 over here, stick it over there. That'll be 5, borrow from here. It has been a long time since I have thought about borrowing, but here we are. So we get 1250 equals 70 times t minus 3. Okay, now I need to do 1250 divided by 70. That's going to be the same as 125 divided by 7. So let's go ahead. What am I saying there? I'm going to divide both sides by 70. That will, yes, get me something like 125 over 7 equals t minus 3. I just canceled out some zeros. And then I need to add 3 to both sides. It can add 3 to both sides. Got 125 over 7 plus 3 equals t, which is an answer, but it would be better to write this 3 as 21 over 7. Get a common denominator so that I can combine these together, and then end up getting something like 146 over 7 equals t. And I don't think that, yeah, that's not going to work out, but that's okay. So we have 146 over 7. What is that? That is a time, so, and what's our time measured in? Let's go ahead and check back again. That's hours. So we're saying in approximately 146 over 7 hours. So all right. Don't let fractions scare you. We can work with fractions. Okay. And now we have some multiple choice questions. So, first, which of the following is the domain of this function? 2 times square root of 6 minus 2x. So, what we want to do is we want 6 minus 2x. We don't want to take the square root of a negative. So what we need is we need that 6 minus 2x is greater than or equal to 0. So, depending on your familiarity with solving inequalities, this might look like a few different things. What I'd suggest you do, whenever you multiply by negatives, things get weird. So I would try to just avoid multiplying by negatives if you can at all help it. And to do that, I'm going to add 2x to both sides. That will get me that 6 is greater than or equal to 2x. Divide both sides by 2, we get that 3 is greater than or equal to x. And now I just need to find what does that mean here. That can also be written as x is less than or equal to 3, which is this one in interval notation. So our answer here is D. If you don't feel as comfortable with inequalities, what I also might have thought about doing is, I know that 3 is going to be a big part. So I'm interested in where is 6 minus 2x equal 0? Where does 6 minus 2x equal 0? Well, that's going to be at x equals 3. You could go ahead and solve that. And we'll notice that this is the only option that had 3 anywhere. If there were a couple others that had 3's in places and we were a little unsure, one thing you could do is you could test either side of 3 and see what happens. So if I plug in something like 0, I'll get 6 minus 0, that's fine. But if I plug in something like negative 100, which is less than 3, then I'll have 6 minus 200, which is definitely negative, and that's not fine. So we see that we are okay. Oh, goodness, those were, let's try that again. That was bad. If I plug in negative 100, then I'm going to get 6 minus negative 200, which is 6 plus 200. So if I plug in 100, that's bigger than 3. That's going to get me 6 minus 200, which we just said is bad. Okay. So what this shows me is that numbers less than 3 are good, but numbers bigger than 3 are bad, and therefore we want option D. All right. What is an inflection point? That's where concavity changes. That's all you really need to know there. So which of those say this? Point where the concavity of the function changes? There we go. Which of the following is the slope of the line represented by the equation 2x minus 6y equals 8? This is one where you could probably memorize a formula that would get this for you, but I don't have that formula memorized. So what I'm going to do is I'm going to solve this for y and then see what my slope is. So we'll have 2x minus 6y equals 8. Subtract 2x from both sides. Get negative 6y equals 8 minus 2x. Divide both sides by negative 6. And it doesn't really matter what this thing is here. It's 8 over negative 6. Fine. But then we're also going to have minus 2x over negative 6, which is the same as if you want to write it negative 4/3 plus 1/3 x. And now that I have it written like this, what's the slope? It's 1/3. All right, last problem. We're almost there. Which of the following is the function graphed here? So this is going to be a lot easier but here's what I want. If I can find, there's kind of like a pseudo point slope form here. If I have an equation of the form y equals m times the absolute value of x minus x1 plus y1, my corner is going to be at x1, y1, and the slope of the right side is going to be m. So let's take a look at this. This here seems to be what we want, because I have a corner at 1, 1, and the slope of this right side is I go up by 2, I go over 1, that's a slope of 2. So my equation should be y equals 2 times x minus 1 plus 1, which is exactly this option here. So we got that. And that's it. We did all the problems. Woohoo. Go, congratulate yourself or something. That's a whole bunch of pre-calc problems, which are kind of like problems you may or may not see on an exam. So I hope you got something out of these videos.